Today we're going to start the next chapter, which is chapter 4, Reactions in Aqueous Solutions. So what's the overall thing about this chapter is this aqueous solutions is, the term aqueous solutions means something dissolved in water. What dissolved in water? It could be sugar dissolved in water. It could be sodium chloride, salt dissolved in water. It could be sodium bicarbonate, baking soda, dissolved in water. Anything dissolved in water, when we have that, is called an aqueous solutions. Of course, not everything dissolves in water. If you just had some random rock, like a piece of limestone, marble, and you put it in water, you could stir all you want. That thing is not going to dissolve. So this chapter, we're assuming it's aqueous, meaning it's dissolved in water. Why do we have a whole chapter about aqueous solutions? That's because everything in, say, biochemistry, everything that's happening in your body is, well, most everything is happening as an aqueous solution. Your body is 70% water. So most of the reactions that are occurring in your body, in your cells, are happening as aqueous solutions. I say most because, your bones are solid. But for the most part, most reactions occurring in your body are as aqueous solutions, meaning dissolved in water. So here's a picture of a water treatment plant. Water treatment plant, every time you wash your hands, flush the toilet, anything that goes down into the sewer system, well, it has to be treated. Okay, we don't just send water directly back into the ocean. It does, many of it that doesn't get recycled does go into the ocean. In LA, there's a major treatment plant. I think it's called the Hyperion one, and that's off of the El Segundo area, near the airport. And so what happens is every time we flush the toilet, every time you wash your hands in anywhere in the west side, that water gets sent out to the treatment plant. There they try to separate out any type of solids, but there are things that are dissolved as aqueous solutions, so they try to get that stuff to settle out, and they also deliberately add beneficial bacteria to try to eat up some of this waste, literally, before eventually it's safe enough to be discharged to go into the ocean. So that's what part of water treatment plants do. They try to remove the stuff that is, well, physically separate stuff out, as well as chemically separate stuff out. When we get the chemicals to separate out, solids that separate out, some of those solids that are mixed together that separate out, they're also known as precipitates. That's what this picture is. These are pictures of when you have two solids or two aqueous things that mix together and they form a solid. Those things are called precipitates. You'll see that term later on in the notes. And so when you have things that are aqueous, dissolved in water, and they mix together, two aqueous things, and they form a solid, it's kind of like curdling in of milk. You can add something, vinegar, lemon juice, anything acidic to milk, and it'll start forming curds. It'll start curdling up. You'll see lumpy parts to it. Those are curds. That is kind of like a precipitate forming. Okay, so this chapter, Aqueous Solutions, is what this title is called. Okay, let's start with, come on, next slide. Why isn't it going? There we go. Let's start with the definition of a solution. Let me move my face. Okay, a solution is a homogeneous mixture of two or more different substances. So when you have two things that mix, whether it's salt and water, sugar and water. By the way, we're talking about aqueous solutions, but they don't have to be in water. You could mix things in oil. You could mix things in you could mix things in gases. You can mix two different gases. Okay, but either way, a solution is a mixture of two or more different substances. They don't. This chapter is aqueous, so particularly we're talking about water here. But it doesn't have. The solution does not have to be a aqueous solution. Solution is just a mixture of two or more different things. There are two parts of a solution. The two parts of a solution are called the solute and the solvent. The solute is a substance present in smaller amounts. The present in smaller amount. Solvent is a substance present in larger amounts. Now, that's a textbook definition of it. However, what if it's exactly the same amount? Well, we're going to use this definition. In the regular chemistry textbook, they say that the solute is the substance being dissolved, and the solvent is the medium in which that solute is being dissolved in. So if you say sugar is dissolved in water, regardless of how much you have, or even equal amounts, let's say you have equal amounts of sugar and equal amounts of water. When you say sugar is dissolved in water, sugar is your solute, the substance being dissolved. Was it being dissolved in? What water is our solvent. So you say X dissolves in Y. Doesn't matter how much X you have, how much Y you have. X is your solute, Y is your solvent. Okay? So again, A is dissolved in B, whatever. Doesn't matter what A and B are. Doesn't matter how much quantity of it you have. A is dissolved in B. When you say is mixed in B, B is your solvent, A is your solute. But we'll stick with this definition. Solute, the substance that's present in a smaller amount. Solvent is a substance found in larger amounts. So we'll stick with that definition for this chapter, though. Okay, so some solute-solvent combinations to make solutions could be like soda. A soda is a mixture of water, is our solvent. Sorry, I mixed up the term. Solvent. And your solute would be sugar, carbon dioxide, whatever flavoring. So if you have a soda, okay, water is your solvent. It's all mixed in water. You have sugar, and whatever stuff that, whether it's cola flavored, whether it's lemon lime flavored. And of course, it's not going to be soda. There's no carbon dioxide mixed in. They don't have to all be the same states of matter. They could be different states of matter. Obviously, carbon dioxide is a gas. Water is a liquid. So, but the point is they mix. And you've all had soda. You know what that is. So if you have soda, it's a mixture of a whole bunch of stuff in water. Other types of mixture is like air. The air that we breathe, it's primarily nitrogen gas, which kind of an inert gas, doesn't do anything. If you breathe in nitrogen, pure nitrogen, well, it won't kill you, except the lack of oxygen would kill you. Nitrogen itself is nothing. In fact, the air is about 80% roughly about 80% nitrogen. What's the rest? Oxygen, which is, good about 19%. And then all your other stuff, including carbon dioxide, also argon, methane, CH4 is called methane, and a whole bunch of other gases that's mixed up in the air. But the air that we're breathing is primarily nitrogen with everything. The second biggest thing is oxygen in the air that we breathe. Nitrogen mixed in with oxygen, and 1% is everything else that's not nitrogen oxygen. Okay, you don't need to know these percentages, but it's a mixture. What we're breathing is a mixture. And in LA, we have even a lot more stuff dissolved in the air. That's why we're number one, the most polluted air city in the United States. Yay. Soft solder, if you don't know what it is, don't worry. But let's say you're trying to solder some pipes or wires together. Soft solder is a mixture of lead and tin melted together. So if they're trying to connect, say, two wires, like, how do you can solder them together? Melt some lead and tin, and they melt together. They form into what's called soft solder. But the point is, it's a mixture. It's a mixture or a solution of two or more different substances. Okay, so that is definition of solution. There's two parts, solute, solvent. Next thing, the term electrolyte. Okay, electrolyte is a substance that, when dissolved in water, results in a solution that conducts electricity. So that's the definition of an electrolyte. You've probably heard of electrolyte somewhere in pretty much like Gatorade. Okay, Gatorade is something that, yes, it says on the bottle, contains electrolytes. In case you're wondering why in the world something like Gatorade would contain your electrolytes, your body, remember, is primarily like an aqueous solution. Your body's mostly water. So why would it need to conduct electricity? Well, how your brain works is it sends electrical signals from your brain through, for those at biology already, your nervous system is going to send electric signals from your brain to whatever body part, whatever muscle to move. If I want to move my hand, if I say lift this thing up, my brain sends a signal from my brain to my hand or my arm, and to move any muscle. It sends us an electric signal. And the most common electrolyte is just plain old salt. Okay. Well, potassium and chloride pump is what you'll learn in biology, but it's not biology class. But it's an electric signal from your brain to your muscles. And as you work out, as you do any type of heavy physical activity, your body will, sweat. And as you sweat, your sweat contains, of course, lots of water, but it's salty. You are losing electrolytes. The chemicals or the way that we send signals from our brain to our muscles, we start losing that, and it's natural as you work out. And so what happens is, we have to replace that. You need to replace those electrolytes and water, because if you're working out, you're sweating, okay? And you probably also want some energy. So Gatorade is primarily water, okay? It is a drink after all. That's the first thing, the main thing. Sugar or some type of energy source. I'm going to tell you it's primarily sugar. Sugar or some type of energy source. And then electrolytes are usually maybe potassium chloride or just even a plain old sodium chloride. Sometimes just sodium bicarbonate, which is just baking soda. So theoretically, you could kind of make your own form of Gatorade, which is just water, some type of energy source, sugar, and some electrolytes, just like salt, baking soda, potassium chloride, if you have that available. But that's primarily what they put in Gatorade. Or just go buy it at the grocery store, which is what I do. But you could just make your own. So there are electrolytes. There are two types. Well, actually, I shouldn't say there's two types. There's either an electrolyte or there's a non-electrolyte. A non-electrolyte is something, when dissolved, results in something that does not conduct electricity. So something that does not conduct electricity in water is a non-electrolyte. What's a non-electrolyte? Technically, if you had pure water and just sugar, they would be non-electrolytes. Sugar doesn't conduct electricity. So if you had pure water, okay, by the way, I'm using the term pure water. You don't really have pure water coming out of your sink. There are lots of ions. There's things dissolved in it that are technically electrolytes in your tap water. Tap water, sorry to break it to you, it's not pure. But if you theoretically had pure water and you put sugar in it, okay, it will not conduct electricity. An electrolyte, however, does conduct electricity. So a strong electrolyte is, move my face. Strong electrolyte is something when you put it in water and there's, it's plugged in, it will conduct electricity. Salt is an example of a strong electrolyte. There are many things. There are also weak electrolytes that in between where it's like, kind of conducts electricity. Okay, we'll get to what types of substances are strong electrolytes, what types of substances are weak electrolytes, what kind of substances are non-electrolytes in the next slide. Well, let's get to it now. So what conducts electricity in solution? By the way, we're assuming it's a solution, so it's dissolved in water or whatever right now. We're assuming that right now. So what conducts electricity? Ions. Okay, cations, anions. Ionic compounds conduct electricity. So if it's ionic, sodium chloride, salt, potassium chloride, lithium nitrate, ammonium phosphate, any ions. How to know ions? That's back in chapter 2 when we talked about how do you name chemicals. If it's ionic, meaning there's metals and nonmetals. Ionic, cations, metals and nonmetals. Metals and nonmetals. Metals and nonmetals. Metals and nonmetals. Those kind of things will conduct electricity. Sodium, which is a metal. Chloride, which is a nonmetal. Metals and nonmetals conduct electricity. Ionic things conduct electricity. So if If it's a strong electrolyte, it will be something that completely breaks apart. The term is called dissociation. And so those are some of the things that will conduct electricity. Okay, I'm going to pause it for now and we'll continue in a second.